Now we discuss what is the algebra of a continuous function. Like algebra of limits, similarly algebra of continuous functions. Algebra means Mishana, Phedana, Gunana, Harana, scalar multiplication. That means the sum of two continuous functions is continuous. The subtraction of two continuous functions is continuous. Multiplication of two continuous functions is continuous. The division of two continuous functions is continuous. And scalar multiplication of two continuous function is continuous. Means let f and g are two functions defined over the common domain. Common domain means this is the domain. This is suppose this is domain 1, this is domain 2, this is d2, this is d3. F is a function from d1 to d2. G is a function from d1 to d3. So this is a function. The domain is this set d1. The domain of G is d1. That means f and g are defined over the common domain. In that case, the sum of two continuous functions, if f is continuous, g is continuous, f plus g is continuous, f minus g is continuous, f g is continuous, f by g is continuous, 1 by f is also continuous. And scalar multiplication alpha times f, this is continuous. This is called the algebra of continuous functions. This is the important theorem. You have to remember this. Understand this first. This is an exemplar problem. Sometimes asked in your CBSE questions. That means the composition of continuous function is continuous. Composition of continuous means we have already discussed fog and gap. That is called the composition function we have discussed. Now prove that if f is continuous and g is continuous, the fog is continuous provided that fog is defined. In the figure, suppose x is a set, y is a set, z is a set, g is a function from x to y, f is a function from y to z. What is this function? That means this is fog is a function from x to z. And g is continuous at x is equal to a. And f is continuous at ga. Then prove that this fog is continuous at x is equal to a. Given conditions, g is continuous at a, f is continuous at ga, then the fog is continuous at x is equal to a. Now this is the proof. If g is continuous at x is equal to a and f is continuous at ga, then show that fog is continuous at x is equal to a. In order to prove fog is continuous at x is equal to a, we have to show that limit x tends to a, fog x is equal to fog of a. If we show this, the proof is complete. The fog is continuous. Now gx is continuous at x is equal to a implies the limiting value must equal to the functional value, means the limit x tends to a, gx is equal to ga. This is equation number 1. It is also given that f is continuous at ga. Since f is continuous at x is equal to ga, limit gx tends to ga, f of gx is equal to f of ga. That means limit x tends to a, f of g of x equal to fog a. That means fog is continuous at x is equal to a. That means the composition of two continuous function is continuous provided that the composition function must be defined. Similarly, the graph is continuous. If this is continuous, this is continuous. Graph and fog both are may continuous, may not continuous. We also know that the graph is not equal to fog. Graph is defined, fog may not be defined. If defined, then this is continuous at x is equal to a. This is called the composition of continuous functions.